Imagine reaching into your pocket right now and pulling out your smartphone. You probably paid a pretty penny for it, right? And you've likely noticed that proud Made in India stamp printed right there on the back glass. But what if I told you that stamp is hiding an incredible, almost unbelievable secret about how our everyday gadgets are actually brought to life? Well, let's dive right into this explainer because the reality of modern electronics is absolutely fascinating. Think about the very device you might be watching or listening to this explainer on. We immediately see the sleek glass screen and the polished metal edges, sure, but what about the microscopic components soldered onto the internal circuit boards deep inside the machine? If you look at them under a magnifying glass, they're incredibly complex. Have you ever wondered just how many thousands of miles those tiny parts traveled before ending up in your hands? Well, here's the stark reality. Up to 80% of those tiny invisible components are entirely manufactured in foreign countries. When millions of these parts arrive here in shipping containers, they're basically just snapped together on an assembly line. It's kind of like putting together a really expensive box of plastic Lego bricks. In a way, assembling a phone right now is essentially just clicking pieces together. It makes the process look less like deep manufacturing and a lot more like being a highly paid toy builder. Honestly, it's the biggest hidden secret of modern electronics assembly. But all of that is about to change big time. A massive shift in industrial policy is officially underway. The Ministry of Electronics and IT just cleared a staggering 7,877 crore rupee manufacturing package. To put that into perspective, we're talking about nearly $1 billion of strategic investment. India is moving past simple assembly to build the deepest, most complex hardware parts literally from scratch. It's basically the difference between just buying a pre-built house and actually manufacturing the bricks and pouring the concrete to build the house yourself. So here's the agenda for today's explainer. First, the smartphone's secret. 2, assembly versus manufacturing. 3, the 7,877 crore plan. 4, 4 hardware building blocks. 5, how it affects you. And 6, securing the future. Let's get right to it. Section 1, the smartphone's secret. Unpacking the 7,877 crore shift. Let's start with the big news that kicked this whole thing off. Union Minister Ashwini Vaishnaw recently approved 22 mega manufacturing projects under what's called the SPECS scheme. In plain English, SPECS stands for the Scheme for Promotion of Manufacturing of Electronic Components and Semiconductors. It's essentially a massive government support system designed to get major corporate giants like Surma SGS, Wipro, and PCBL Chemical to build heavy-duty factories right here at home. Section 2, assembly versus manufacturing, understanding the baseline. Now, to really grasp why this investment is an absolute game changer, we kind of need to get our baseline facts straight. Over the past decade, India achieved something truly incredible. We became the second largest mobile phone manufacturer in the entire world, churning out hundreds of millions of devices. But economists have consistently pointed out a massive structural weakness in exactly how we were doing it. They called this weakness screwdriver assembly. To understand what that means, let's use a neighborhood bakery analogy. Under the basic assembly model, you don't mill the wheat, you don't churn the butter, and you don't even bake the sponge cake yourself. Instead, you order pre-baked cake layers and frosting and plastic boxes from overseas. When they arrive, your staff simply stacks the layers, spreads the frosting, and slaps your bakery's logo on the box. While that definitely creates local jobs for decorators, the complex chemistry of baking and the vast majority of the profit, that stays with the foreign suppliers. And here's the real danger. What if the guy selling you the sponge cake decides to triple his price overnight? What if his delivery truck breaks down? Your bakery goes out of business, and you don't even know how to bake a cake to save yourself. That vulnerable position is exactly how our electronics manufacturing has worked for years. You see, a smartphone isn't just a shiny glass screen. Inside, there's a printed circuit board, or PCB. It's that internal green board you've probably seen if you've ever dropped and completely shattered a gadget. That board is packed with literally thousands of microscopic components. And for years, we've imported nearly all of these raw parts from East Asia. If an international supply blockade happens tomorrow, the factories stop, and the price of your next phone? It could double overnight. Section 3, the 7,877 crore plan, deep localization. The IT Ministry's entire goal with this new blueprint is achieving domestic value addition. That's just a fancy economic term for making the raw ingredients ourselves. It's deep localization. It means we aren't just putting our name on the final product anymore. We are owning the recipe, processing the ingredients, and completely controlling the kitchen. Section 4, 4 hardware building blocks.
To pull this insanely ambitious plan off, the approved proposals are setting up high-precision industrial units. And let me tell you, building these factories is incredibly difficult. It requires massive investment and exact scientific precision. They're being built to produce the fundamental components of modern hardware natively. There are 4 fundamental pillars to this plan. We're talking about multi-layer PCBs, passive components, electronic substrates, and massive integrated systems. These 4 blocks are literally the foundational elements of every single digital device you interact with, from the moment you wake up to the moment you go to sleep. So let's take a microscope to each one, starting with the foundation.
The first block is multi-layer printed circuit boards, often called high-density interconnect PCBs. Let's bust the jargon here real quick. This isn't just a simple, flat sheet of green fiberglass. Think of it as a microscopic, multi-story highway system. It contains dozens of conductive copper layers laminated together, designed to perfectly route electrical signals between processors. If these copper layers aren't perfect down to the absolute nanometer, the electrical signals literally crash into each other, and your phone shorts out. Achieving that nanometer precision is exactly why we previously relied entirely on imports.
The second block focuses on passive and discrete electronic components. If the microchip is the brain of your phone, these passive components, things like capacitors and inductors, are the cardiovascular system. Have you ever used a cheap off-brand charger and felt your phone get incredibly hot? Well, that's bad electricity management. These tiny passive components are what stand between your expensive microchip and a complete electrical meltdown. They safely regulate currents and smooth out voltage spikes, ensuring your device doesn't instantly fry the moment you plug it into a wall outlet. Moving to the third building block, which is led by specialized companies like PCBOL Chemical, this is all about electronic substrates and advanced chemicals. Manufacturing modern electronics requires incredibly high-purity industrial chemicals. Think of the thermally conductive resins as the high-tech sweat glands of your phone. When you're playing intensive video games or scrolling for hours, these specialized chemicals pull the trapped heat away from the processors, so the phone actually stays cool in your hand. We absolutely must produce these natively to keep our own factories running. The final pillar covers integrated systems and electromechanical assemblies. Supported by industry leaders like Surma, SGS, and Wipro, this block goes way beyond just consumer smartphones. We're talking about the heavy-duty hardware needed for the electric vehicle you might drive next year, the solar power inverters on your roof, the 5G telecom towers that give you seamless streaming, and even industrial aerospace automation. These companies are literally building the backbone of our infrastructure for the next decade. Now, as you can imagine, setting up the automated facilities for this kind of microscopic science is painfully expensive. That's precisely why the SPS framework is offering a 25% capital expenditure subsidy. To do this right, companies have to build clean rooms. We're talking about environments hundreds of times cleaner than a hospital operating theater. Workers have to wear full bunny suits because a single speck of dust dropping from an eyelash can ruin a $1 million batch of components. This massive 25% financial subsidy dramatically lowers that huge barrier to entry. And guys, the economic scale here is just mind-blowing. These 22 units are projected to generate over 28,000 crore rupees in total production value. But more importantly, going back to our bakery analogy, this pushes our domestic value addition from current levels of about 20% all the way up toward 50% and beyond. That means half of the profit on every device stays right here, fueling the local economy, rather than being wired off to an overseas supplier. We finally go from just icing the cake to actually baking it. Section 5. How it affects you, jobs, gadget prices, and security. Now, you might be sitting there thinking, okay, this sounds great for the national economy and for massive corporations, but what does this actually mean for my daily life? Well, it really comes down to 3 major areas that will touch your family and your wallet. First, we're looking at a total evolution of high-tech engineering careers. Second, this directly impacts the reliability and price of your everyday gadgets and dramatically lowers the cost to repair them. And third, it provides a vital layer of national economic security. Let's break those down. Let's look at the career impact first. This initiative is projected to create 75,000 high-skilled jobs. If you have a kid heading into college, or if you're looking to pivot your own career, this is where the money's going to be. We are graduating from routine warehouse packaging into advanced cleanroom operations, industrial robotics, and multi-layer circuit design. Plus, think about the next time you crack your phone screen or fry its battery. Right now, replacement parts have international air freight fees baked into their cost.
By manufacturing these passive components and PCBs locally, the repair shop right down your street gets their parts for a fraction of the cost, making your repairs significantly cheaper. And on a national level, producing these blocks locally means our economy is totally shielded against international maritime shipping blockades.
Section 6. Securing the future. Technological independence. To summarize this explainer, we are stepping out of the stark reality of relying on 80% imported parts. This nearly billion-dollar approval marks our decisive transition from basic surface assembly to deep-tiered hardware self-reliance. It ensures that our digital infrastructure remains fully operational regardless of external economic shocks.
Which leaves us with a really fascinating thought to consider. Now that India is actively investing thousands of crores to manufacture the foundational internal components of modern electronics natively, do you think our domestic hardware brands will soon be able to directly rival the global tech leaders? Or will foreign component makers find a way to maintain their dominance? Let me know what you think, and I really hope this explainer helped you understand the incredible hardware revolution happening right under our noses.